So hello everyone, I'm going to do my presentation in English. That's how I've done it mostly, so I feel most comfortable there. My name is Cédric, I'm one of the founders of Symvio, and at Symvio we believe that there is already a lot of data available in buildings, and this is an incredible lever to increase the efficiency of technical operations in buildings. So I want to introduce you to Matthias. Matthias works for a large German internal facility management company in a retailer, a supermarket chain, and he has to continuously reduce his operational costs despite the growing complexity of the systems that he looks at. And this is a task that's becoming increasingly complex the lower or difficult the longer he is in a building. Also, his internal customers, the retail stores, want him to be more proactive. Today he's very reactive. They complain that he only comes once they call him. They want him to be there before they even know something is wrong. And the second is he has a lot of turnover of labor, and he wants to be able to share the knowledge among his different people and ensure the quality of the service that he gives. So, and this is exactly where we come in. We help him discover problems in the technical equipment in his buildings. So if we talk about technical equipment, this is mainly HVAC systems and cooling systems that we look at. So we automatically find problems for him and help him prioritize these. We help him manage these problems by telling him what he can do. And then we help him share this with the different stakeholders and his team that he has so that the problems are being solved in the buildings. So if you move on to the next slide, I'll give you a quick example on how this can look like. This is an example that we have done for a large German pilot project that we're currently doing with a large German retail supermarket chain. So each store there has about 100 cooling devices, refrigeration systems, and they have in a region, they have about 150 stores. And Matthias is in charge for these 150 stores, which each over 100 fridges. So we look at the fridges to simplify in the stores, and we automatically identify which fridges have abnormal behavior. We prioritize the problems that we find in these stores based on different parameters that we define with Matthias. So that's based on occurrence, cumulated time of occurrence, impact they might have, and tell him which fridges he has to look at in priority. So this is what we see on the left, and in this particular case, so there were 61 fridges that had problems, and we told him these two are the fridges that you should look at in priority. And there, for this particular problem, we then tell him briefly what the problem is. In this case, it's a difference between inlet and outlet temperature that indicates to a problem with the defrosting. So we tell him this. And then on the top of this screen, we tell him what he has to do in this case. There's a quick checklist on what he should do. So in this case, he should check whether the doors are closing properly, whether there is a problem with the exhaust air, and whether the inlet air supply might be blocked. And based on this, he can directly go to the fridge that has a problem, and he knows, or his people know what to do. Today, he doesn't have that type of machine level information. The way he works today is that he only has aggregated power or electricity consumption. He doesn't know immediately how to link this to a particular machine. So he has to work his way down from stores that have outlier consumption to see what the problem is. We immediately tell him what could be a cause of a problem, and so he goes and looks there. This saves him about 2 days a month. He spends about a week a month doing just this. So if we go to the next slide, this summarizes basically what we do. We give him automated identification and diagnostics of problems in his technical equipment, mainly HVAC systems and cooling systems. We give him automated insights, and so he has real-time transparency on machine level of the buildings that he's in charge of, so he saves time and energy. The way we do this is that we connect to the control systems or the building management systems of the building, or additional sensors that we can install. We link this with secondary data that we have in the buildings or the equipment that we look at, and we apply machine learning. We learn how these machines behave in nominal behavior, and then we can detect outliers and tell him how to act. This has been developed in close collaboration with the Fraunhofer Institute for Solar Energy Systems in Freiburg, where we are a spin-out of. And if we come to my last slide, this is a quick overview, the next slide, of the team. So we are quite new. We have been founded in November 2019. And we have a team that combines on one side the data experience from the Fraunhofer Institute with deep technical experience also as a, so Sven, he was a facility manager at a large German retail store, and myself, I have a background in research and as well in Siemens. So thank you very much for listening to me, and if you have further questions, feel free to reach me at cedric@symv.io. Thank you very much.